Hello guys, welcome back to my channel, Memo African Motives, still working on engineering science for N3. So in this platform we shall be focusing on the continuation actually that we had from this question paper, which was on March 2016. Now working on forces there. So you're given a question on forces, which is to state the definition of equilibrium of forces. So what we have, guys, on the definition of the equilibrium forces. So there we are given that the equilibrium of forces, the equilibrium of a system of forces is this in the same plane is that single force which will balance the system of forces. So it is that force actually that we are talking about as the equilibrium of forces. So that's the definition there that you just need to use. Solve analytically the magnitude and direction of the resultant in Fig 3. All right, so there we need the resultant, guys. All right, so not wasting much time there, guys, as we know that from the previous part that I talked about. Okay, so this is 300. Let's just put it normally here. This is our 300 here. So remember, I told that a force is supposed to be taken from the point, not to point. Yeah, so you have to continue with this, take this one out like this. So this is going to be our 250 Newton here. Okay, now with the positive, so as you can see, the angle between this angle and this angle are the same. So this is going to be 30 degrees here. So this one is no longer there. We are now working with this one. All right, or you can just put a negative if you want to use it, but it's very, very risky for most of you to use that one. Okay, so remember, we need the horizontal components here. So this part we have talked much about this type of equation, so I'm just gonna rush through and see what we have there. So the horizontal of this one, remember, always horizontal uses cos theta, and this is on the positive, so it will be 250 cos 30 degrees. So it's 250 cos 30 degrees because it's positive there. And here there is no horizontal. This is a straight vertical, so it can't be a horizontal. So there's nothing that you're going to take here. Okay, then this one is a straight horizontal, but on the left, which is negative. So it's going to be negative 150. All right, then here is this one. So you're now left with this one here. It's the, if you were to cross check like this, this is on the positive, so it's going to be 200 cos 45 as a positive. So it's 200 cos the angle which is between 45 degrees like that. All right, so if you are to use your calculator properly there to simplify this, you're going to obtain 207,92770 something like that, which is going to give us 207,928 in newtons. 3 decimal places, 1 2 3. This is gonna change this to 8. So that is your horizontal component. In this case, we move on to the vertical components. Remember, they use sine theta, and these are vertical components like this. So as we are to cross check here, our vertical component is on top here, which is a positive there. So this one is going to be a positive, so it's 200 sine 30. 250. That's 250 sine 30 degrees like this. All right, previously we didn't take this one because we said it's a straight vertical because of this, guys. You can see 99. So this one, it's a straight vertical and it's on top, which is a positive, so you're just going to add 300 there. So it's plus 300 because it's on the positive. Last time we said this is a straight horizontal, so it can never be a vertical. Never. That is a horizontal, so it can't change to be a vertical, so it's totally out. Then we take this one. Yes, it's a vertical, but take a closer look. It's below the horizontal line here. It's this side, so it's a negative. So this one is going to carry a negative, so it will be negative 200 sine 45 degrees. 200 sine 45 degrees. That's what we have there. All right, so once at this stage, your calculators, guys, they are very good at this work, so you can just use your calculator at once which is 5, 7, 8, 6, yeah, something like that. Then you can round off to 3 decimal place. That's gonna be 5, 7, 9. And these are newtons, guys. This is our vertical. So let's just take a closer look. This horizontal here is a positive, and just like this, which is going to the east. Remember, it's east and west, so this is to the east here. And this, our vertical, is positive like this, so which means it's going here to the north. So this is to the north. So at the end, this is going to give us where we are going to find the resultant. Since this is east, you're going to have like something like this to have, that is the resultant diagram now, like this, because this one is going to the east and to the north. So it can, when they are all positive, it's only the first quadrant. So this is your 207.928, which is the horizontal, this one, your horizontal. And your vertical, this one, which is going straight to the north, is this one, which is 283,579. So you have to find this resultant and this direction, which is theta, which is between east and north. So yes, the formulas, they are important to know them, but also to represent on a diagram also is important, just to show that you know what you are talking about there. So we know that the resultant is equivalent to, remember, this is our hx and this is our vy. So to find this, that is the Pythagoras theorem, because this is 90 degrees. So it's hx squared plus vy squared there, which is going to be the square root of, we have to substitute, guys, our hx, which is a 207,928 squared, plus the vertical component, which is a 283,579 squared, like this, everything under the square root. So this is gonna give us something like 351,640,587, something like that. All right, so if you round off to 3 decimal place, it can be 351,641 newtons, because everything was in newtons, so it's going to remain in newtons. If it was kilonewtons, then you have to find it in kilonewtons. Okay, then the theta here, which we know that is going to be arctan, because we are given what? Opposite and adjacent, and it's only tan from your soccer tower there, which has got opposite and adjacent. So tan theta is opposite over adjacent, so which means theta is arctan opposite, which is vy over hx. That's going to be arctan. It's going to be arctan vy there, which is 283.579 over 207.928. Just take here vertical, horizontal. So this from your calculator is going to give you 53,75. Is it 75? Yeah, 75 degrees, something like that. That would be your theta there. But as I was saying that, I was saying here that it's between east going to the north, because it's east here and the north. Sorry for that. Sorry for that. Let me just try and adjust this side. All right. So it's between this east here, guys, going to the north, like this. So if it is east going to the north like this, that means I can just write this as a resultant which is a 351. So this is 351.641 newton, like this. Then it's east. Remember, we said it's east going to the, this is the resultant that we have taken. Then we want to write this angle, so you said east going to the north, so it's east of this, so it's east 53,75. This one, you write this angle as it is, which is 75 degrees to the north. That is now the direction. So always whenever you find the resultant, it must go hand in hand with a direction there. So that's how, guys, these questions can be asked. So as you can see, that's what we needed there to obtain those 4 marks. Okay, then the other question is, 3 forces shown in fig 4 below are in equilibrium. Calculate the magnitude of the unknown forces analytically again, which means by normal calculation. So what we have here, guys, by normal calculation, these forces are in equilibrium. So which means that we can actually use the cons. As for me, this is the best that I have to use, because this force is going, let's just close this diagram here. Right, let's just close this. This is your angle here. So let's formulate our equations here in terms of P. So there are so many ways of forming equations in terms of P, but this is the one that is best for me. As for me, it's best. Okay, I'm going to use this concept. Remember that the sum of forces going up is equal to the sum of forces going down. Remember this, guys, we talked about this previously. So if the force is going up, this one is the one that is going up here because the positive, this one is a negative. This one, it's a horizontal, so you can't refer to 560 because it's not going up or down, it's in the horizontal. So F up is equal to F down, which means P, this up, this one, it's a vertical component. This one, like this, it's a vertical line. So remember, vertical lines uses sine theta, so which means P sine this angle of 35 degrees, P sine 35 degrees like this, should be equal to this one of Q, which is Q sine 40 degrees. So it's equal to Q sine 40 degrees like that. So these two are equal. So when you are equating the two, you don't work with the sign. No, you don't work with the sign. All right. So someone could have used another way, but from this concept, there's nothing that you're going to use there. All right. So let's just say we have something like 1s. I'm going to come back and simplify further. Yeah, but for the meantime, let me just leave it like that. Then we work with forces to the right equal to forces to the left. That is now working with the horizontal component. Okay, so F right, or let's just say F left, is equal to F right. Either way. All right, or F right is equal to F left. Okay, so F left, what we have on the left, this is our horizontal this time. So we are working with this horizontal, which is from this point. This is to the left and this is to the right. So we are working with these ones on the negative, these ones. So it's P sine this time. So it's P sine cos, sorry, horizontal, because this is horizontal, so it's P cos, because you're working with this side here. So it is going to use cos, so it's P cos 35 degrees, which is combined together with these two, which is Q cos 40 degrees. That is plus Q cos 40 degrees. Remember, these two combined together, they must give us this force to the right, which is 560, like that. So we now have two equations that need to be worked on so that we can solve for P and Q. So how are we going to do this, guys, from these two equations? All right. Let's start with equation 1. From equation 1, I can make P to be the subject or Q to be the subject there from equation 1. All right, so from equation 1, we have a P sine 35 degrees, which is equal to Q sine 40 degrees. So let's just make maybe P the subject, which means I'm going to divide by sine 35 degrees, divide by sine 35 degrees like this. So these two definitely gonna cancel. So P is equal to, I want you to divide sine 40 divided by sine 35, which is going to give us actually 1,12,066, something like that, but with a q there, so you can round off to be 1,12. This 6 is going to change into 1, so it will be 121 q. So p is now equal to this, which is now our third equation. From the first equation we have formulated another equation again. All right, then what am I going to do with this? I'm going to substitute this into equation 3, into equation 2, because I was working with equation 1. So I substitute into another equation here. So let's substitute here. So substitute equation 3. Now we have equation 3 into 2. All right, into equation 2 and solve. So that is the concept. You have to substitute this into equation 2, then you can solve. So let's substitute in place of p here. In place of p, we are going to substitute with this value here in place of p. So it's 1,121 q like this by cos 35, because we just substituted this p, but there's still cos 35. So it's going to be by cos 35 like this. This remains as it is, which is plus q cos 40 degrees, which is equivalent to 560 there, like that. So from this equation we can calculate the value of q. So let's just try and simplify so that we can solve this one, guys. Here the first part that we need actually is to find the value of cos 35, which is going to give us something like 0,918 something like that. So you just multiply this and this together. So if you multiply those two together, you're going to obtain 0,918. Yeah, because there's a 2 there, so just leave it like that. Like if you combine these two after multiplying these two, okay, but there's a q here, plus find this one, cos 40, that is 0,766 there, q. So cross check properly there, because in your memo they didn't give this accurately, guys. This is going to be cos 40 at this, which is equal to 560 like this. So now I can add, because this is q, this is q, so these are like terms. So I can add these two values together, which is going to give us 1,684 q like this. All right, so that's what you're going to have, which is equivalent to 560. So what can I do now to obtain the value of q, because I'm just left with q as we can see here. So definitely someone has to divide this 1.684 like this, so this can cancel. So therefore my q is going to be this and this, which is if you divide, it's going to be this decimal 33 2. This is a 2 here, comma 541, yeah, 56, something like that, okay, which is going to give us 332, 542 newtons like that. So these were newtons, so it's going to remain in newtons. All right, so cross check there on your memo. There's something that is weird. They didn't do it the way it was supposed to be actually done there, but this is actually what you were supposed to do, and you just correct one or two things there. So I have the value of q, so it will be easier for me to find the value of p. Why? Because already I have my p here that I have made the subject from equation 3. So I'm just going to take that continuation, since p is equal to 1,21, it's 1,121 q like this. So p is going to be 1,121 by q, which is this q that we obtained here. This is 332,542 like this. So if you multiply these two, you're going to obtain 372,7795, yeah, something like that. So if you round off to 3 decimal places, this is gonna change this into a 10. It adds this one and gives it an 8, so it's going to be 372,78. so this is gonna change into 8 because it will be 10 and gives a 1 there. So that will be 8, and this is now a 0 there. So you can write this 0, or you can just leave it like that. So that is the value of P, and this is the value of Q. So these are the values that we're being asked to calculate or to find from this concept or this question. Okay, then the other part to finish this question was to calculate the nature and magnitude of the forces with reference to component A, B, and BC. And that's 4 marks to complete this to give us 15 marks there. So what do we have here, and what are we going to do? I've talked about this type of equation a lot of times, where let's start with AB. Okay, let's just start with AB. So for AB, we are going to use the concept of F up and F down like that. So which means you're going to remain with this, that is 3.4 there. So let's just take this piece here on AB. Remember AB, you work with this piece, you're ignoring C, so there's 60 degrees there. So that's your A there, your B, that's 60 degrees here, and you've got 350 newtons going up. All right, so since we are having F up, the force that is going up, so remember F up is equal to F down. So F up, which is this 350 Newton, is equal to, remember it's a vertical component, so always when you are working with a vertical component you use sine. So it's going to be AB sine this angle. So it's AB sine 60 degrees like this. So to find AB, definitely you have to divide by sine 60 degrees. Sine 60 degrees like this. So this gonna cancel each other. So AB is equal to 350 over sine 60 degrees like this. All right, so this can be simplified to give us 404. Yeah, that's 404,14,1451, something like that. So that's 404,145. And cross check, this was in newtons, so this is going to be in newtons again. So our AB is going to be in newtons, and that is a strut. That AB is going to give us a strut. That's the nature there. Okay, that's S there. So this type of equation, guys, if you are to cross check on all the questions that we had on forces there, you see that we tried by all means to explain this part. So you can just relate from those ones, guys. I think that's the best. AB we are done, then we move on to B and C. So this B and C, this one I'm going to take this way. Let's just, since AB is now there, so this one I'm not going to involve it this time. I'm just gonna ignore it. Okay, let me just put my A and my B and my C this time here like this. All right, that's 60 degrees here. Okay, so this is what I do as for me. I worked with F up. This time I'm going to work with this force to the right, okay, because this is like what I want to calculate, BC. So it's to the right, okay. So F to the right is equal to F to the left this time. So it means we have to work with cos, because it's all about horizontal cos. So to the right, that is your BC, the one that you want to calculate. So it's BC is equal to the left, AB. Now there's an angle in between because C is already in the horizontal, so that is why you don't need an angle there. But this AB to be taken down now, it will be AB cos. So this one will be AB cos 60 degrees, which is the angle between. So remember the concept of forces, guys. So but we had AB before. Yes, this AB was there. So this BC is going to be AB, the one that we had before. This our AB here, which is 404,145 times cos 60 degrees, like this. All right, so if you multiply properly, this is gonna give you 6202, 725, which is 202,073 newtons. So something like that. That is going to be your BC. So as you can see, guys, and this is a time. Okay, so that's what we had on this platform, working on forces. Still just looking at some questions that we might want to work on. So this platform, guys, that's what we had, and we shall meet again, still working on engineering science N3, working on question papers and revisions as we prepare ourselves for the exams which are ahead of time. Take note, guys, the exams, they are ahead of time, and we have to prepare ourselves before the date. So that's what we are having till we meet again.